Hi children, today I am teaching about some important questions from thermal physics lessons. Now we have to see about characteristics of heat energy. So what are the characters of heat energy? The first one, this is a substance, hotter region, this is for colder region. The first one, heat always flows from higher temperature to lower temperature. The heat energy, we have to applying some amount of heat energy into the substance. That energy will moving from higher temperature to the colder temperature, lower temperatures. Second one, you have to apply heat energy. The mass of the substance is not changed. So mass of its system is not changed due to heating. Third one, for any exchange of heat, heat gained is equal to heat lost. This is a substance. You have to exchange the heat energy. Now applying heat energy, the heat will be exchanged from hotter to colder region and colder to hotter region. So in which time the transformations takes place means the two regions, hotter and colder regions, will having the same temperature gain. That is the place itself, the heat energy will be transferred to both the ends. Okay, so that is the point. For any exchange of heat, heat gained is equal to heat lost. Heat gained means absorbing heat energy to the particular substance. Heat lost means the releasing heat energy from the substance. That is for heat lost. So characteristic of heat energy is the 3 points will be more important. Heat always flows from higher temperature to lower temperature. Mass of a system is not changed due to heating. For any exchange of heat, heat gained is equal to heat lost. The next one, effect of heat energy. So what are the effect you should apply heat energy to the particular substance? The first one, temperature of a substance increases. So you have to applying heat energy into the vessel, but definitely the temperature of the vessel becomes increases. Okay, you know that well. Second one, the substance change state, solid to liquid and liquid to gaseous state. Suppose taken an ice cube in a vessel, you have to apply heat energy into the ice cube. The ice cube will changes to liquid state. The ice cube is a solid state. You have to apply heat energy. Some smaller amount of time later, the ice cube will be changes to the liquid. So solid to liquid, and further again applying heat energy, the liquid will be changes to gaseous state. So that is the point. Substance change state, solid to liquid and liquid to gas. In which condition you apply heat energy. Third one, substance will expand when heated. So the substance, you have to apply heat energy, the substance will be expanding here. So the 3 points are the effects of heat energy. So what are the expansions we will hear? So now we have to see about the 3 types of expansion. First one, linear expansion. Second one, superficial expansion. Third one, cubical or volume expansion. So the 3 expansions will be here for you have to apply heat energy. Okay. The first one, what is the meaning of linear expansion? You have to apply a heat energy in the iron rod. After some interval of time, the iron rod will be changes the length. Okay, you have to apply heat energy. The length will be changes in the iron rod. So L0, this is the initial length of iron rod. Then del L is the small change after applying heat energy. This amount of length will be changes to the iron rod. So this is for linear expansion. You should apply heat energy. The length of the rod will be changes. So equation for linear expansion, del L by L0 is equal to alpha L into del T. Del L means small changes in length, original length into the final length. L0 is the initial length. Alpha L coefficient of length expansion. You have to apply in unit temperature. We should increase the unit amount of length will be greater. That is for coefficient of length expansion. Del T is a temperature change in temperature. So the second one, superficial expansion, that is for aerial expansion. Okay, superficial expansion means you have to apply heat energy into the particular area. Then after some times the area of the substance will be some expanding. So this is for A0 is the initial area of the substance. Del A is the outer area will be the increasing area due to applying the heat energy. So del A is the change in area. So equation del A by A0 is equal to alpha A into del B. So del means changing, okay. Del A means change in area, initial length area to changes to the final area. Del T change in temperature, alpha A coefficient of area, A0 initial area. And third one, cubical expansion, otherwise called as volumetric expansion. You have to apply heat energy in the cubical system for a particular substance. The volume of the substance will be increases. This is for initial volume of the substance. V0 is the initial volume of the substance, and del V, the outer region, is defined as the volume expanding of the particular substance. So del V is a change in volume. So cubical expansion means you have to apply heat energy to the particular substance. The volume of the substance will be changing to the particular value. So del V by V0 is equal to alpha V into del T. Del V means volume change, V0 initial volume, alpha V coefficient of volume, del T is a small change in temperature. So what are the effects of heat energy means, one of the effect means the substance will be heated, the particular substance will be expanding due to heat energy. So what will be the expanding? So expansion means there are three types of expansion here: linear, superficial and cubical. Linear means length expansion, superficial means area expansion, cubical means volume expansion. So three types of expansions here. Is it clear now? So one of the problem based for the expansion, okay. So first the problem here, a container whose capacity is 70 ml is filled up to 50 ml water. It is heated that the particular substance, the liquid filled substance, it is heated down. Initially the liquid falls from 50 ml to 48.5 ml. So applying more heat energy, the level of liquid rises to 51.2 ml. Find the apparent and real expansion. In this problem, listen here, the initial level of the liquid will be 50 ml. First applying heat energy, the liquid level will be decreases for 48.5 ml, and then further again applying heat energy, the liquid level increases to 51.2 ml. Now you have to find out the apparent and the real expansion. It is very simple sum. First solution, the level of a liquid initial L1 equal to 50 ml and L2, the first false level 48.5 ml is L2. Then next one L3 is here the final level of water 51.2 ml, and you have to find the apparent expansion. What is the equation for apparent expansion? Is equal to L3 minus L1. L3 is the final level of liquid, L1 is the initial level of liquid. So apparent expansion 51.2 minus 50 ml is equal to 1.2 ml. This is the answer for apparent expansion. Now you have to find out the real expansion. Real expansion is equal to final in L3 final minus L2 is the decreasing level of water. So L2 value is 48.5, L3 value is 51.2. The two values are subtracting here. We get the answer 2.7 ml. So the real expansion is more value from the apparent expansion. So real expansion will be greater than the apparent expansion. So the real expansion is the final level of water level increases, okay. The apparent expansion level, the falls, first you have to apply heat energy, the water level will be falls from the original value, okay. That is for apparent expansion. Okay, is it clear now? First you have to fix the value L1, L2, L3, and you have to find out the apparent expansion using that formula and real expansion using this formula. So you got the answer, okay. Thank you, students.